Now that we've practiced factoring as a means of converting from standard form to intercept form, let's put that to work for us by solving quadratics by factoring. Solving quadratics, finding zeros, and finding intercepts are synonymous. They mean we're going to be doing the same thing. When asked to solve a quadratic function, you're really just trying to find the x-intercepts, similar to what we did when we graphed in lesson 4.2. And factoring puts us in intercept form. Now, if we're just asked to factor and not solve, then we stop with the parentheses. So maybe you have something out in front, and x minus p and x minus q. You leave it in parentheses form. But to take it one step further, we'll apply the zero product property. And that just means you set each x term equal to 0 and solve. Kind of like what we did when we found x-intercepts in lesson 4.2. So here's our game plan. When solving, finding zeros, or finding intercepts, the first thing you want to do is set your equation equal to 0. So set the equation equal to 0. If you have like y equals or f of x equals, just plug in 0 in its place. And now it's kind of like working backwards to figure out what value for x makes it equal 0. Step 2, then we'll apply what we learned in 4.3. We'll factor completely. And then step 3, we will apply the zero product property. We'll call that the ZPP for short. All right, let's practice this down below. When asked to find the zeros for each function, we're basically just solving for x. And it says, reminder, always check for a common factor. That's fair game for any part of this process. Question A, f of x equals x squared minus 8x. Notice there's no constant there, but we'll see how that plays out when we factor. The first step is to set it equal to 0. Where that f of x is on the left-hand side, I'm going to plug in 0 as a placeholder. My quadratic's on the right-hand side, so let's see what we can factor. Notice there's no constant to split, that's 0 at the end, but we can check for a common factor. Look at x squared and look at 8x. They both have an x in common. If we factor that out by dividing, then there would be a parenthesis to see what's left over. If we take x out of x squared, we would have x left over. And then we have minus. If we take x out of 8x, we have 8 left over. Looking at that right-hand side, x squared minus 8x factors into two parts, x on the outside and x minus 8 on the inside. And then it's time for the ZPP, the zero product property. Now what's unique about this is anytime you see x, whether it's on the outside of the parenthesis or in a parenthesis, you set that entire part equal to 0. So what it looks like for the x on the outside, that's a pretty easy answer. X equals 0. That's an x-intercept. Now the parenthesis is very similar to what we had in lesson 4.2. If we actually want to find our x-intercept, remember we have to solve for x here. Make sure to take the time to move that 8 to the other side by doing the opposite operation. And we get x equals positive 8. Those are the two x-intercepts for that quadratic function. My hope is that if you're fluent in 4.3, this will seem pretty easy to do. Again, start off by setting the equation equal to 0, and then determine how you would factor. Numbers that multiply to get negative 32, but also add to get negative 4. If you write that list over out on the right, there are several options. I'm going to go right to the factored form, 4 and 8. Those are the numbers I want. But now notice one of them should be negative so that we add to get negative 4 in the middle. That would mean my 8 has to be negative. 4 times negative 8 would be negative 32, and 4 plus negative 8 would be negative 4 in the middle. Those are the two numbers I'm going to use to factor. We'll do our two parentheses, and now x squared will split up into x times x. The 4 is positive, so it's plus 4. The 8 is negative minus 8. Once you have it in factored form, apply the 0 product property. And now x plus 4 equals 0. Move 4 over. Please, again, take the time to do that. And we have negative 4 as an x-intercept. X minus 8. And move the 8 over. X equals positive 8. There's our two x-intercepts. When you're asked to solve for x, it means to do the same thing. So I'm trying to give you different sets of instructions that you'll see on your homework that mean to do the exact same thing that we've been doing. If we want to solve for x, we first start off by setting y equal to 0. And now notice in this example, everybody, there's a number out in front of x squared. Lucky us. Taking a look at the the 27 with the x, and then the 18, notice there are no common factors. That means we have to apply the second part from lesson 4.3. We're going to need to multiply 5 times negative 18, and that would give us negative 80. Just kidding. That would give us negative 90. I don't know where that came from. 5 times negative 18 is negative 90. All right, so lots of factors of negative 90. And when you're doing this independently, you might just need to list them all out until you find a pair that work for you. I know that 3 times 30 in some way can give us negative 90, but we have to make sure they also add to get us that negative 27x in the middle. That means the 30 has to be negative. Now recall from 4.3, this is a times c, and then we have to split that bx term. So let's go ahead and do that right now. The 3 and the negative 30, you can technically write them in either order. I like to always write my negative term first and the positive term second, but it's up to you. And then drop down the 0 equals, oh, wrong color, thank you, 0 equals, and then drop down the 5x squared and that constant minus 18. So from here, remember, we have to actually put 2 parentheses around this now, and that doesn't mean that that's the factored form. When we put 2 parentheses around the first 2 terms and the second 2 terms, now we look for that common factor. What could we take out of 5x squared and 30x? I know we could take a 5 out of both of the numbers and an x out of each of the variables. That means we can take out a total of 5x. If we take 5x out of 5x squared through division, we have an x left over. Minus, if we take 5x out of that 30x, 5 goes into 30 6 times. Our goal is to have a matching second parenthesis. Let's see what we get. In 3x minus 18, I see we have the 3 and the 18. 3 goes into both of those numbers. So let's hope for the best. If we take 3 out of 3x, again, we have our x left over. We have a minus. 3, like I said, goes into 18 6 times. So now our parenthesis matches. Remember what that indicates for us. Ooh, hang on, I've got to do 0 equals. Sorry about that. What that indicates for us is that x minus 6 is one of our 2 factors. Now remember from yesterday, those numbers on the outside create that second factor. 5x plus 3. Whew, that's the factored part. Now apply that 0 product property. If we set x minus 6 equal to 0, and we add 6, we get x equals 6. There's one x-intercept. Whenever you have that a value that's other than 1, that's likely going to indicate that one or both of your x-intercepts are going to be fractions. If we set 5x plus 3 equal to 0, move the 3 over, and then we have to divide by 5, we would get x equals negative 3/5. And there you have your 2 x-intercepts when you're solving for x. And of course, we're going to see examples that just kind of change things up on us. If we look at this equation right here, 13x squared plus 21x equals negative 5x squared plus 22. Now remember, we're trying to solve for x, so we need to set this equation equal to 0. There's no y or f of x or anything. What that means, everybody, is that we actually need to move all of our terms to one side. So what I'm going to consider is the fact that I've got an x squared term on each side. I would like to keep it positive. That means I'm going to actually add 5x squared right underneath the 13. And I need to move my 22 over as well. But that's the constant. And notice there's nothing on the right or the left-hand side that it combines with. So these guys all cancel on the right, leaving us with 0, which is what we wanted. Now on the left, 13 plus 5 is 18. Oh, you guys, 18x squared. Seriously. All right, plus 21x minus 22 equals 0. This is going to be crazy. Let's try for a common factor and hope for the best. 18, 21, 22. Ugh, not fun. That means we have to multiply 18 times negative 22. And we should get negative 396. What? That's crazy. All right, carry on. We'll get over it. Now we have to think about all the factors of 396, one positive, one negative, that would actually add to get positive 21. I've already done this problem a few thousand times, so I know the answer. We could do 1 and 396, we could do 2 and a big number, but the answer is going to be 12 and 33. I've done the legwork for us, so we don't have to go through all the numbers. However, if you were doing this on your own, you would have to list out all those factors. However, here we are. Okay, we want one of our numbers to be negative, but we want them to add then to get that positive 21 in the middle. That would mean the 12 has to be negative and the 33 stays positive. All right, let's go ahead and split that bx term. Forgot to write that out earlier, so let's do that now. So these two will give us 21x. I'm going to put minus 12x first and then positive 33x second. If we added them together, then we'd get back to that 21x. From there, again, we're just going to drop that first term straight down, 18x squared, and then drop that constant down, minus 22, all the while remembering to set it equal to 0. Parentheses around the first two terms and the second two terms. 18 and 12. I know 6 goes into both of them. X squared and x, we can factor an x out. Now we have to see what's left over. If we have 18x squared, but we divide by 6x, we would have 3x left over. Minus 12x divided by 6x, 6 goes into 12, twice evenly. Now that second parenthesis, I've got 33 and 22. And I know that there isn't like a small number, but I know 11 actually goes into both of them. If we take 11 out of 33, we get 3x. And if we take 11 out of 22, we get 2. And our parenthesis matches. That's what we're going for in this process. Now remember, if our parentheses match, that means that's one of our factors. The two numbers on the outside create the second factor. They're both positive. I'll write that as 6x plus 11. All right, you know the drill right now. Set them each equal to 0 separately. And we're actually going to have two fraction answers this time for our x-intercepts. Divide both sides by 3. One x-intercept is x equals 2/3. The other one, 6x plus 11, apply that 0 product property, move 11 over, and divide by 6. Our other x-intercept is negative 11/6. Wow, that's a crazy process to solve for x. Last one. What are the intercepts for the equation? Whenever we ask for intercepts specifically, we're looking for the x-intercepts. If we were asking for the y-intercept, we would only really need that for graphing purposes. First thing I want you to do is set the equation equal to 0, just like we've done all the problems up above. 2x squared minus 3x minus 9. All right, what I'd like you to do now is try this one on your own. Try to factor and then set each parenthesis equal to 0 and solve. Pause the video and see what you can do. When you feel like you've got it, press play, and then we'll be done with today's lesson. All right, were you able to come up with x equals 3 and x equals negative 3/2? I certainly hope so. Looking up at my work, I did the a times c method and I got negative 18, recognizing that 3 times negative 6 would give us negative 18, and 3 plus negative 6 would give us negative 3 in the middle. I split my BX term, and I found common factors of each parenthesis, and the pink parentheses matched, which means that's one of my final factors, adding those numbers on the outside to give me the other factor. And then you guessed it, I applied the zero product property. So if you were fluent in 4.3, 4.4 was just an additional extension to that process. And that's it for today.